show my gratitude to the folks at Universitas Bangka Belitung that allowed me to come here and continue to work with me, particularly Professor Eddie Nurjaya, my host and advisor, and then all of the administrative staff and professors and support staff here at UBB that are very welcoming. And of course, last but not least, my research team that I work with every day. I have two full-time assistants, Unita and Alita. They're recent graduates of the UBB biology program, and I couldn't do the study without them. And then we had two part-time assistants that helped as well with the initial setup of the project, Mutiara and Tirma. So I appreciate everyone that's part of the project. Thank you. And you already heard a brief introduction about me. Everything in there was true, of course. And in that last portion, Dr. Nurjaya mentioned that my hobbies include hunting and fishing. And here I included this picture. This is me and my grandfather hunting wild ducks in America, out in a marshland in Tennessee. And I feel like it's important to include this and talk about it because ever since I was very little, since I was a young boy, I have always been hunting and fishing and out exploring in nature, and really those experiences, those memories from when I was young are kind of what drive my passion for ecosystems and forestry, and knowing the importance of having ecosystems and natural places to be able to explore, and that kind of drives my passion for the work that I do. This is about my research interests and ideologies, like Dr. Professor Eddie Nurjaya mentioned. I'm interested really in the reclamation of ecosystems that were once forests and then were destroyed through whatever reason, particularly through mining, and then taking those destroyed ecosystems and making them forests once again. And the same goes with waterways, streams, and rivers that have been degraded through industrial use and resource extraction, and making them clean again. Here, this is an example of a project that I'm kind of interested in. Like, this was a coal mine in West Virginia, the United States, and then this is a stream off of that same coal mine. And as far as I'm interested in the resource portion of it and the ecology portion, but I'm also interested in the aspect of holding industrial leaders accountable, the people that actually do the resource extraction, holding them accountable for their actions in destroying ecosystems, and working with them to help give their resources to building ecosystems again. And that goes into this next topic called circular bioeconomy, which you'll see is very a prevalent theme in my work and my presentation here. And basically what that is it's kind of like the triangle of recycling, with reduce, reuse, and recycle. And what it is getting industries that use biological materials, and maybe don't yet use biological materials, to work together in order to have a more sustainable industrial complex in regards to the use of natural resources and biological resources. And then last but not least, down here in the corner, this is a quote from Elon Musk. And it says, "Possibly the most common error of a smart engineer is to optimize a thing that should not exist." And I really like Elon Musk's kind of mindset and methods for how he's become so successful in his science and engineering research that he does. And that is, a lot of times people spend a lot of time trying to optimize one very small part of a big system, when in reality that small part almost should not even exist. So here, this kind of flow chart from Elon Musk says to make the requirement less dumb, delete the part or the process, simplify or optimize the design, accelerate the cycle time, and automate. And that's something that I kind of try and focus on, doing things as simply and efficiently as possible to still achieve in final result. Next, I want to talk a bit about why this work is important. I know for people like us that study biology, it might seem obvious. Of course, biology ecosystems are important to have, and when they get degraded, of course, they should be restored. But I really just want to spell it out that, right now across the world, we're in a climate change crisis. With carbon emissions and rise and alterations of global temperatures and fluctuations of seasons, we can feel it here in Bangka and all across the world. A great analogy for this is the bathtub analogy that I really like, where the bathtub is the amount of carbon that can be sustainably held in the Earth's atmosphere. And this faucet here, this tap, is the production of carbon emissions through industries and cutting down forests. And then carbon sinks act as the drain plug for that tub, where they absorb carbon and hold it, like uptake by trees and plants and uptake by the oceans. And right now, the tap is flowing faster than the drain. And it should be said that the easiest way to amend this problem is to cut off the tap or reduce the flow of the tap. However, my research and this research is focused on how to make the faucet drain bigger and how to increase the amount of carbon sink available. Besides that, additional to that, down here is a chart from a paper published in 2013 called Carbon Emissions from Forest Conversion by Kalimantan Oil Palm Plantations by Carlson et al. And through their study, they were able to estimate that the total amount of carbon absorbed through 1 hectare of rainforest in Kalimantan per year is this number, 243 tons of carbon per hectare, which is a really high number. Some other forests in other parts of the world are only about 40 to 60 tons per hectare. So that just goes to show you how important the native rainforests are here in Indonesia, and especially as carbon sinks for the world. And on that note, here in this next graph is a paper published in 2014 by Ranjan and Gorai, titled "The Assessment of Global Carbon Dynamics Due to Mining-Induced Forest Cover Loss During 2000 and 2019 using Satellite Datasets." And basically, it's a comparison of all the relevant countries in the world and how they are deforesting, cutting down rainforests in their country for the use of mining. And you can see that far and away Indonesia blows every other country out of the water. They're absolutely top on doing that, which is certainly not a good thing when you look back at everything else that I've just mentioned. And then lastly, before we get into the meat of my project, I want to do a quick case study, which will kind of be a primer for the inspiration for the kind of thing that I'm interested in. And this is a very popular case study out of Princeton University in New Jersey in the United States. This here on the left is a publication published by the Princeton University Press titled "Orange is the New Green: How Orange Peels Revived a Costa Rican Rainforest." I'm just going to read this for you real quick. In the mid-1990s, 1,000 truckloads of orange peels and orange pulp were purposefully unloaded onto a barren pasture in a Costa Rican national park. Today, that area is covered in a lush, vine-laden forest. A team led by Princeton University researchers surveyed the land 16 years after the orange peels were deposited. They found a 176% increase in above ground biomass, or the wood in the trees, with the 3-hectare area studied. Their results are published in the journal Restoration Ecology. This story, which involves a contentious lawsuit, showcases the unique power of agricultural waste not only regenerate a forest, but to also sequester a significant amount of carbon at no cost. And then that publication in the journal Restoration Ecology is this here on the right: low-cost agricultural waste accelerates tropical forest regeneration. If you haven't read these, I would encourage you to go and read both the publication and the press release and the publication. I'll read this snippet from the publication as well. Lower cost tropical forest restoration methods framed as a win-win with business and protected area partnerships dramatically increase the scale of tropical forest reforestation, providing a variety of societal and ecosystem benefits, slowing global biodiversity loss and climate change. Orange waste deposition significantly elevated levels of soil macronutrients and micronutrients in samples taken 2 and 16 years after application. Our results point to promising opportunities for valuable synergisms between agricultural waste disposal and tropical forest restoration and carbon sequestration. Now, a quick takeaway from this is the time scale. They talk about 16 years is the end measurement, and then between 2 and 16 years after application. That's fantastic. However, I only have 9 months here at Universitas Bangka Belitung, so I'm unable to do a project of that scale, but we're trying to kind of mimic this system on a smaller scale using a variety of methods that have been established. And now we'll get into the introduction of the actual project here. As I'm sure the local folks know here in Bangka, there's 2 main industries here. The first one being tin mining for tin ore, which is a prevalent element used in all types of products. I believe Indonesia is the #2 exporter of tin in the entire world. At the current moment, most of the tin mining has moved to offshore dredging around Bangka, which means that not much of it is done on land on open strip mining anymore, but that does mean that there are a lot hectares and hectares of open pit mine that just kind of sits there and is still degraded, and very little effort has been made to reclaim the land. And then, of course, we have the palm oil industry, the oil palm plantation industry here on Bangka Island. I believe Indonesia is now the #1 exporter of palm oil in the entire world. And there are a lot of issues with palm oil. As I'm sure you all know, it's a contentious topic with deforestation for plantation conversion. But additional to that, there are these large amounts of waste material that are produced from the palm oil industry. And for a lot of years, that material was just burned, which is, of course, bad for the environment. But now there have been a lot of recent initiatives to figure out better ways, more sustainable ways to deal with that material. There are a couple different variations on that material. There's the empty fruit bunch and the mesocarp fiber, the palm kernel fiber, are kind of the main 2, and that's what we focus on in this study. And I, along with other people in this field of study, believe that kind of these 2 problems are the answer to one another. Similar to that orange peel case study from Costa Rica. And here is just a quick look at some areas. Here's Bangka, where we're about right here, yeah. And then there's just some big old open pit tin mines here in central Bangka, and then this is central and south Bangka. And then you can even see very often right adjacent to these areas is palm oil plantations. So this is the scale of the problem here. And there have been some studies previously published, and these, especially from Universitas Bangka Belitung, from some of the great professors here, studying this process, this proposed process of using the palm oil waste material as a organic soil additive on the tin mines. Here's one where it looks at how that process affected heavy metal uptake and production of eggplants. Here's one that looked at, I believe it was mustard plant, and then this one was pineapple. And one thing that all these studies that I've read have in common is that they kind of look at how this process in the soil is happening and then how it affects plants. And one thing that I thought would be good to study and think is necessary to study is how that process affects the soil itself and the properties of the soil, because soil properties are vital in choosing and making decisions in land management. And so as us biology folks know, we're familiar with the process of ecological succession. Here is a picture of an abandoned tin mine. This is actually the research site that we are using for our field site for this experiment. And it looks to me, I think you might agree, that it looks like a barren environment all the way back to the first stage of primary succession, or maybe we've got some pioneer species just starting to come up. And yeah, along with the concept of ecological succession, we know that before you can have trees through primary succession, you need to have grasses and bacteria and lichens, small annual plants as pioneer species. And for this project, we proposed that citronella grass, or Cymbopogon nardus Randall L, would make a fitting pioneer species for several reasons, because one of those being, well, two main reasons. One, the citronella grass is adapted to growing in harsh environments, like low nutrient environments. And two, because it has a economic value in that it is often planted for harvest to have the essential oil distilled from the plant, which is citronella oil, which is used in a variety of different products. It has economical value. And actually, many studies have shown that when citronella grass is planted in harsh environments under controlled conditions, it can actually produce more concentrated amounts of that oil, which increases its economic value. So that was why we chose that. Here is a general statement of purpose. I'm going to read this word for word just to drill the idea home. The statement of purpose for this project is to evaluate and advocate for a sustainable strategy for reclaiming post-mining soils in Indonesia using palm oil waste materials, while simultaneously assessing the potential of Cymbopogon nardus as a viable dual-purpose crop that supports ecological restoration and provides economic value through essential oil production. And here are 4 hypotheses which we are testing. 1, soil amendments with organic waste products will significantly improve soil fertility parameters compared to unamended mine tailings. 2, amended soils will show a consistent increase in soil fertility parameters over the 4-month period, while unamended controls will remain stagnant or degrade. 3, there will be a significant interaction effect among the type of organic material and its treatment form in plant growth and soil properties. And 4, there will be a significant interaction effect among the type of treatment applied and the plant biomass and oil yield, as well as oil quality. All right, now we are going to get in. If you have your mic on, could you please mute yourself? Thank you. Now we're going to get into research methodologies. So we have a total of 6 treatments that we're testing, 5 treatments, 5 treatments and 1 control. That control is just tin mine tailing only. Then we have 1 which is cow manure only, so no palm oil, just cow manure. Then we have 2 which are the the palm waste in their raw forms, raw empty fruit bunch and raw palm kernel fiber. And then we have two which are composts made from those palm oil materials. Here's a picture of my team and I mixing, making the compost. That compost is made from the palm material itself, cow manure, and then this EM4 fermented bacteria solution, which is a common ingredient in agricultural practice here in Indonesia. And actually, we are using the recipe for compost, which comes on the bottle itself. That's a very cheap product, very readily available. So the process for making the replicates looks like this. The empty fruit bunches that you might have seen in the previous picture come in big bunches, not really easily used for, not really easily used directly in a, could you mute yourself, please? Thank you. Not really easily used in a soil application directly, so we had to do a lot of chopping, mostly my team. I'm very grateful for, spent a lot of time finally processing that material by hand into smaller pieces. Ideally, you would have a machine that's able to do that, and we did work with several people to try and find a machine, but as far as we know, that machine that's able to process that material does not yet exist on Bangka. After the material was processed, I'll add the palm kernel fiber was small enough that it didn't need to be processed, only the empty fruit bunch did. So after that initial processing, we either made compost or didn't, and then we combined the treatment material with the sand and filled planter bags with that material for use in the greenhouse. And then after that was done after a week of anaerobic decomposition in the compost. And then we mixed the treatments and the tailing and added them into planter bags and put them in the greenhouse for another 3 weeks of decomposition, at which point we planted the citronella grass. Here is some diagrams of how the experiment is laid out in both the greenhouse and the field site. In the greenhouse here, in both areas we've got random block designs. 3 planter bags is 1 replicate in order to reduce noise in the data. And then here on the field site, we've got 5 planter holes per replicate, again, to reduce noise. And yeah, they're all randomly oriented in block designs. And here are some pictures of the actual sites. This is the greenhouse, of course, just like in that diagram. And then this is the field site. You can see that 5-hole design, and those holes were filled with the treatment just like the planter bags are. And then here is the location of the field site, and here is the greenhouse at UBB, only about 10 kilometers apart. The field location is in Reading Panjang village, and the soil that we used in the greenhouse is actually brought from the field site, so it's the same soil. And as far as data analysis goes, we are collecting a multitude of plant biometric data from the citronella grass, such as stalk length and tiller count and basal diameter. And then for the soil measurements and data analysis, we are sending samples monthly to PT Biodiversitas Biotechnology Indonesia, or ICBB laboratories in Bogor. They're an accredited soil laboratory in Bogor. And these are the parameters which we are testing every month. Every month we're testing soil texture, pH, phosphorus, potassium, total organic matter, total nitrogen, exchangeable cations, and cation exchange capacity. And then at the beginning and at the end of the experiment, we're also testing bulk density and then a variety of heavy metals content in the soil: sulfur, magnesium, lead, arsenic, chromium, and copper. And finally, with the citronella grass, once it's done growing after 4 months, we are going to distill it into its essential oil using a basic steam distillation method. That'll be done here on UBB campus. And then we also have another research partner called their PT Mitra Ayu. They're one of the largest essential oils companies in Indonesia, and they're vertically integrated, so they do all of their own research and development. They have a very astute, very professional biological research department, which myself and Professor Nurjaya were able to visit in Padang. This is one of their factories in Padang, and this is one of their plantations in Solok Highlands in West Sumatra. And they have some really fancy spectrometry equipment that they use to analyze their essential oils for all different parameters. And they will be doing the analysis on our essential oils that we distill here. Here's a brief timeline of the project as a whole, or at least in my time here. We only started, as you can see, very recently in July 2025, which the project kind of started when we created that first batch of compost. That's when the stopwatch started. After that, we made the replicates and took the first soil sample in the greenhouse, in the green, and then in this red is the field site work. So we mirrored that process also in the field site afterwards. And then we planted the citronella grass and then took another sample and then repeated that on the field site. And then after this point, monthly, we are taking the soil samples. Actually, tomorrow we'll be taking the third soil sample at the field site, all the way up until the month of December, when we will harvest the citronella oil or citronella grass and distill the oil and send it for analysis. Hopefully receiving all data back to us by early February, at which point we'll be able to begin to formally analyze and compare the data, which will be done using an analysis of variance. Here we'll take a quick look at some preliminary data. The only data that we have now is the only soil data we have now is from this first initial soil sample from when we originally made the greenhouse. So it's not very much, and it can't really draw conclusions from it because it's just a singular data point, but it's still interesting to look at, something to look at. So here is a summary of all of the different soil parameters and how the different treatments compare to each other. You can see things are kind of mostly the same. And then in some of them, the one that's just cow manure takes a big spike. And then for some of the heavy metals here, only like for calcium, for example, the cow manure only replicate or treatment group was the only one that even showed any signs of having that heavy metal. So yeah, you can't really extract any conclusions from this, of course, but it's still something like this is the first round of data. And then here are some specific zoomed in data points from that big graph. Something that's interesting here is this pH. There's kind of a big span even across from the amended treatments, and then of course you have the cow manure only one, which is very basic, and then for some reason this empty fruit bunch compost is also very basic. Yeah, of course, this is kind of promising. This is kind of what we're looking for. What is to be expected is this organic carbon where everything is all kind of bunched here in one group, and then the cow manure only is way high. One thing that I thought was interesting here is this carbon to nitrogen ratio. an ideal carbon to nitrogen ratio in a composted treatment is about 30. So we're still very low here, although, of course, it was just made. But one thing that I thought was interesting was the composted materials have lower carbon nitrogen ratio than the treatments that were just the raw material themselves. And it's a bit considerable. So that'll be something to look for how that changes, hopefully in the future. And then we have this cation exchange capacity, which I can't make out anything about why this is the way it is, but it is the way that it is. And we'll see how that changes in the future as we continue to collect and receive more data in return. So we're going to talk about some potential outcomes and their implications. So for hypothesis one, which going back to the beginning of the presentation, if amended treatments show statistically higher soil organic carbon, such as available nitrogen and phosphorus, exchangeable cations and cation exchange, and lower bulk density than controls at the first sampling and or by month 4, then it can be implied that palm oil residue amendments are effective low-cost inputs to jumpstart fertility on tailings. Composting or direct amendment can be integrated into reclamation protocols for post-mining land. And some potential follow-up research that needs to be done would be to test the persistence of improvements beyond 4 months and their effect on microbial recovery, which that beyond 4 months is going to happen. My team is going to continue the research for at least for a little while after I leave and go back to America. But so microbial community recovery would be a very interesting thing to research in the future as well, if any of the students are interested in the topic. For hypothesis number 2, if soil fertility metrics in amended plots trend upward across the 4 sampling dates from month 0 to the end, while controls remain flat or decline, and continue to have low carbon or increasing compaction, and then it can be implied that benefits are not just immediate, but accumulate and progressive, and will continue to increase over time. Monitoring soil conditions through the reclamation process is vital for knowing amendment timing and quantities. And through this project, evidence for progressive improvement strengthens grant proposals and policy arguments for investing in amendment-based reclamation and promoting reclamation as an alternative economical system. And then for hypothesis number 3, if different amendment and form combinations produce distinct results, interaction term significance in ANOVA for biomass and soil metrics, then it can be implied that not all residues are equal. Recommendations must specify both, and pre-treatment composting. For a cost-benefit analysis, if composting greatly improves performance, including composting costs and time into feasibility assessments, if one raw material performs well without composting, then it may be recommended where resources are limited. And further, it prompts investigation into why materials differ and why they might promote different long-term soil conditions. Oops, hypothesis 4, not 3. If some treatments increase biomass but reduce oil concentration, while others produce less biomass but a higher oil concentration or a different or more desirable oil profile, then it can be implied that restoration strategies must balance maximizing total oil production versus targeting higher oil quality concentration based on market conditions. Using combined agronomic and oil data to compute revenue per hectare under different amendment regimes, which is important for community adoption decisions, and an adaptive strategy, a mixed approach could be recommended. An early stage amendment to build up the soil, and then limited stress management to enhance oil quality at harvest. In short, through this experiment, it has scientific significance in testing how palm oil waste can improve important properties of degraded soils. It has practical significance in the fact that citronella can grow in mine soils and yield a marketable product potentially. It has societal significance for the potential fact that potential livelihood models for communities on post-tin mining lands could adopt this system and thrive, hopefully. Lastly, we'll talk about some problems that we've already faced in the research. First and foremost is that the line between active tin mining site and a finished tin mining site there is no distinct line. Once the land is done being formally mined for tin by the big mining company, by PT Timah, it is often used for other purposes afterwards for reclamation, besides reclamation to a more natural state, such as smaller mining companies and continuing to mine, or even illegal mining happening. And then sites are often used for as quarries for sand to collect sand for construction purposes and other things like that, other than being made to reclaim. Number two, most of the equipment needed for the large-scale application for this process is also used by the mining and tin and palm oil industries, which has made it difficult occasionally to find resources for the project itself. And of course, even talking about a bigger scale would probably be even more difficult. For example, when we were trying to prepare our field site, we needed a piece of heavy equipment to be brought in to level it. But at that time, there was a boom in the price of tin. So all of the heavy equipment was being used for mining tin. And we had to go through various people to try and find a piece of equipment that was free to come and do the work on our site, which would certainly be an indication of how things would go in large-scale application. Additionally, some necessary machinery required for this process does not readily exist on Bangka Island. Like for processing the empty fruit bunch, you would certainly not be possible to hand chop with butcher knives enough of that material for hectares and hectares scale purpose. It would just take up too much time. And a machine for shredding that material does not exist on Bangka yet. Of course, maybe you could just simply throw out the palm empty fruit bunch onto the mine lands, although that would certainly take a much longer time, more on the scale of like the orange peels in Costa Rica, 16 years in order to break down and promote plant growth and ecosystem development. And then lastly, that I'll mention right now, safe water sources are uncommon near mine sites. A lot of the mine tailings that I'm sure you may have seen, or there's bright blue tailing ponds, that water is highly acidic, usually around pH of 3 to 3.5, which means it's totally unusable for plant growth, and therefore that tailing pond reclamation also seriously needs to be addressed. And that's it. I'm right at 40 minutes. That's it for my presentation. I really appreciate you all inviting me to speak here and lending me your ears and listening. I hope you found something interesting or learned something. I will leave I believe my email may be in the chat. I should put my Instagram in there as well if you want to reach out and contact me with any questions. But I believe now we will get into a discussion section. So thank you very much.
Okay, thank you very much, David, for your detailed presentation. And also you have also at the end of the presentation, you also mentioned about the challenge we have with your project. I think you again, I think we should thank to the Biology Student Association of the UBB for this happening to make happen. And this is the first for International Biozone, but it's the 11th Biozone seminar series. And I think you also have the passion on to land and water restoration, and also you mentioned about the use of the agricultural waste to accelerate for the forest regeneration, tropical forest regeneration, and also you're talking a lot about the importance of the carbon sequestration. And And then you mentioned about the importance of the rainforest in the tropical for the globe, and you are using the two of the oil palm plantation, which is you said that that is the issue of the palm oil plantation. That is they're using the empty fruit bunch and also the fiber, mesocarp fiber of BKF. And you're focused on the process of soil amendment. So you have four hypotheses, and I think the audience, maybe you can give like a suggestion or maybe asking question regarding to the focus of your research. And we are using the Simbobocon nardus. I think there are, you just mentioned about because this species is adaptive to the harsh condition, but also you are looking for the economic values of the species for the society, but also you mentioned about the challenge you have so far. I mean, the equipment, you mentioned about the excavator, but also the simple thing, I mean, the machine, I mean, how to chop the empty fruit punch. Actually, it has been addressed and about this machine for the last several years, but until you come with this project, we cannot find it, and so it's just like a proposal, it's just a plan. So I think it is a challenge for the UBP because we also have the program study machine technique and also tambang. That may be also a challenge for UBP can give support and this for this thing. And well, I think that is about your presentation is good, very detailed, and also the timeline. And I think that I will invite participants, the online participant, to give a suggestion to you and your team about the project, and also maybe have a ask question. So I leave it to the participant then. Thank you.
Thank you. So there's one question right now by Zamila. Zamila, would you like to unmute yourself and ask your question, or if not, I can just read it. That's okay.
Can you mention Samila? Is that you? The first question raised? Samila?
Yeah,
Okay. Yeah.
I can just read it. That's okay.
Okay. Yes, David.
Zamila says, let me introduce myself. I am Zamila Nariza, a student from UBB. And I would like to ask about how the acidity level, pH, and heavy metal content in palm oil waste can affect the reclamation process. Additionally, how does the level of heavy metal contamination, such as tin, found in Bangka, influence the application of palm oil waste? How can we implement a similar approach to countries that have previously conducted reclamation using palm oil waste materials to adapt them to the conditions in Indonesia? That is a great question, Zamila. Thank you very much. I am going to read it just again, just so I can totally understand it. Yeah, that first part of the question, the acidity level and heavy metal content in palm oil waste, how that can affect the reclamation process. I think that's kind of the thing, one of the things that we are testing throughout the process, and how that the answer to your question basically will be revealed hopefully as time goes on and as we continue to collect data. I'm not sure that the initial thought would be that the pH would be leveled from the palm oil waste material will help to level the pH of tin mining soils. That would be yeah. And then actually in previous studies that I mentioned earlier, especially the ones from UBB here, they have shown that heavy metal content in the soil is significantly improved. Heavy metal uptake in plants is significantly improved when using the palm oil waste as the amendment. So that is already proven to have a beneficial relationship. And then on to the next part, how does the level of heavy metal contamination influence the application? I'm not sure that necessarily, maybe I guess on sites where there is more, the conditions are more harsh, because it's certainly not a uniform condition across every site. That's why pre-amendment measuring and monitoring is so important. You have to figure out the specific factors on that specific site before you can prescribe a treatment. And so on sites that have higher, harsher metal contamination may need more palm oil material to be added, or may specifically need compost versus palm oil waste, or maybe need palm oil waste and then compost. That's a great question, and that's something that certainly ought to be experimented on in the future. As for the last part of the question, the questions that are previously conducted. How can we implement a similar approach to countries that have previously conducted reclamation using palm oil waste materials to adapt them to conditions in Indonesia? I'm not sure that well, maybe in Malaysia they've used palm oil waste materials on X mines, and I think in some nations in Africa they also have done that. And I think that question comes less from a hard science standpoint, like a biology standpoint, and that's more of a political and economic question, as far as how do you develop programs to institute these practices? Where does the money come from, and who does the work, really? And those are things that I'm not that I'm an expert in anything, but not an expert in that. That's not my background, but there are certainly people doing work on that, and including one of my good friends who's currently working in Jakarta, working on a similar project. So, yeah.
Good morning, Pak Edi. Good morning, David. I would
Good
like to
morning,
ask
Ibu
you,
Diana.
David.
Yes.
Okay, because this is about your research.
Yes, ma'am. Do you have a
Your
question,
speaker
ma'am?
still muted, Budiana.
Oh,
Budiana, still muted.
I will.
Okay, could you please
There we go.
provide information about the research? Microbes, about the microbes.
Yeah, sure. The microbe communities is something that is potentially very interesting. Certainly, there is going to be an increase in microbial activity anyways. We even have seen that in a lot of the various treatments, when we initially planted them, there was an initial upshoot of fungi that come, which is a great indicator of an increase in microbial communities. My project specifically doesn't have an aspect to where we're monitoring microbial communities throughout the time, but I think that is probably the next thing that needs to be studied on this subject, and I think that would be a very good project for a student to do if someone is looking for a project kind of on this subject to investigate the microbial community change. Does that answer your question, Ibu?
Okay, thank you. I just asked about the gift from you, from AMINEF. Thank you, David. Thank you, Pak Edi.
Thank you, Budiana. I think you raised the one important thing that we haven't done it for this project is about the fungi, the micro. So probably we can invite the students from maybe from other department, like agri-technology department. Maybe you can use this as long during our research. So maybe we can hope there is a student there. But before we continue to Siti Nabila, there is one person where you raised several minutes ago.
Okay.
Ragita, would you like to speak up about your question? Is
Thank you, sir, for the opportunity. So I want to ask for the what extent can biodiversity, flora, and fauna recover after reclamation of farm-martin mining land, and what solutions are being considered to address the security of safe water source near mine sites and to improve tailing ponds reclamation? Thank you, sir.
Thank you. That is a great question. The question, I'll reiterate, and I hope I'm getting this right. There was two questions. One was, what is the projected outlook for flora diversity on reclaimed mine sites? And the second one was, what can be done to secure safe water sources near the mine sites? And that first question is very interesting, and it kind of totally depends everywhere you go, and it definitely very much depends on the existing flora that is around the site already, and that is and yeah, the available seed bank. Certainly, there's no available seed bank in an ex-tin mine. That has all been destroyed. But the seed bank that is in the surrounding areas and how those plants are dispersed onto the site as far as natural floral regeneration goes. The bigger the mine, generally, the bigger the mine, the harder time the middle is going to be. That's edge effects. I'm sure we're familiar with that concept in ecology, edge effects, and it'll be harder for the middle based on how bigger the mine is. That's just through natural regeneration. Of course, through concerted effort of planting, you can increase the amount of floral diversity by planting plants. But through natural regeneration, it all depends on the flora that are already surrounding the area, which is another that goes into, like, earlier we talked about how there was a lot of palm oil plantations surrounding these ex-mine sites now, which means that there can hardly not be any natural regeneration except for what's brought in by animals or the wind. And then as far as the water security question goes, I haven't done too much research on methods of water security. I do know there is one paper that was published, and it's very interesting. And it actually talks about this system that are using palm waste material as a main ingredient in building artificial wetlands out of the out of palm oil tailing ponds, and yeah, making an artificial wetland with the palm oil waste material as a main ingredient, and then through a series of different channels and artificial wetlands, they are able to purify the water in using a natural system. And that's a very interesting paper. I would recommend that you read it. I forget the name of it, but if you look up like wetlands on tin mines, palm oil, it'll come up, and that's a very promising outlook. So what's next?
on the chat room, Siti Nabila, can you read it?
Siti Nabila,
Yeah.
yes, okay, I see it.
Yeah.
Okay, Siti Nabila says, let me introduce myself. I am Siti Nabila, a student from University Bangka Belitung. Certainly you may ask me a question. Based on Ranjan and Gorai's study on global carbon dynamics due to forest cover loss to money, yeah, that map earlier, how can the utilization of palm oil waste help reduce the impact of carbon emissions on former tin mining areas? This is a great question. And basically, where you have an area that is a totally degraded tin mine where it looks like a desert, right? That is not doing anything for carbon removal. It's not absorbing any carbon, which is totally not ideal. And the addition of any type of plant that grows on that site is going to sink more carbon than nothing will, of course. The eventual end goal of reforestation of these sites is the ultimate carbon sink source. So in using the palm oil material as through the process that was described in the presentation, in order to have the end goal of being a forest, that end goal forest is going to be the optimal system for reducing the impact of carbon emissions is an optimal carbon sink is a forest. I hope that answers the question.
Okay, thank you. The next one, Betty.
Betty Putri Askia, yes. Betty says, excuse me, sir, thank you for your very useful presentation. You're welcome. Thank you for listening. My name is Betty Putri Askia from Bangka Belitung University. In the context of rehabilitating former tin mining land in Bangka, whether the addition of organic waste such as empty oil palm fruit bunches, palm kernel fiber, and compost can significantly improve soil fertility indicators compared to untreated land. Whether the compared to considering that former tin mining land in Bangka generally has low nutrient content, sandy texture, and high soil acidity, do you think the integration of these organic materials can accelerate soil quality recovery and support the growth of adaptive plant species in these degraded ecosystems? Furthermore, how do you see the potential for scaling up this approach as part of sustainable reclamation practices in Bangka Belitung? Great. The short answer in the first real question is yes, I do think that the integration of the organic materials can accelerate soil quality recovery and support the growth of adaptive plant species in integrated ecosystems. That has already been established, that fact. Definitely has already been established, and through previous studies, and my study particularly is focused on also how does that specifically look like in the soil, and then what does the soil look like so that it can be the best practices can be chosen for that for the plants on that site in the future. As far as furthermore, how do you see the potential for scaling up this approach as part of sustainable reclamation practices in Bangka Belitung? That's a great question. And that previously I mentioned a similar question is highly dependent on more of a political and economic basis. And that's not necessarily my field of background. But one thing that can be said is that there has to be a fund created for it, because that work is not free. And as a matter of fact, it is quite expensive because it requires manpower and heavy equipment and trucks moving back and forth material, which gas, that's all expensive things. And so money has to come from somewhere. And I'm not very familiar with how the Indonesian system for creating funds like that works. I know how it could happen in America, but I'm not sure if that transfers at all. So I can't really comment on how that is potentially to be scaled up, but I do certainly think that it ought to be. And someone with more of a background in that kind of political thing should take a look at the process of scaling that up. So thank you for the question.
Another queue is Selma.
Yes, I see. Selma Gita Nusa, thank you for the presentation. I am Selma. Thank you. Did you mention about, so you did mention about citronella grass. Why is citronella grass considered a suitable crop for cultivation on post-tin mining soils? And what advantages does it offer in terms of soil recovery, carbon sequestration? And what's so special about this grass? Does it have something special from the structure? Great question, Selma. Thank you very much. Citronella grass is adapted to grow on harsh conditions where it's less than optimal. It's a very hardy plant. And as a matter of fact, its oil that it produces, that is that secondary chemical, is like a defense mechanism for growing in poor conditions. It's an interesting fact that essential oil is very useful for medicinal products because it has a lot of antioxidant qualities to it, and those antioxidant qualities come because it is often grown in very harsh conditions. It's adapted to harsh conditions, which produce a lot of oxidation within the plant, which is detrimental to the plant health. So it produces the antioxidant oil to help rid of those oxidated chemicals. So that's how it is special for growing on the harsh conditions of an ex-tin mine. And it can even produce, there have been studies that show that it produces more of that oil in certain harsher conditions than others. And that's kind of one of the things we're testing. As far as carbon sequestration goes, certainly it's not going to hold as much carbon as, say, a tree, but it is a plant, so it is sequestering more carbon than nothing. And as we talked about with ecological succession, before you have trees, you need to have grass. So it is also serving as a pioneer species in order to stabilize the soil. So thank you.
Okay,
Next.
before we continue to Wenny, I think that Samila is raising hand again. Samila, still any question from you? Or you just give a comment, Samila?
Excuse me, Mister. May I ask again if there are risks in its application if that waste is used excessively? Thank you.
I'm sorry, if what was used successfully? What was it? What was the question? Could you please repeat the question, Zamila?
Sorry. May I ask again if there are risks in its application if that waste is used excessively?
Oh, okay. In each application, if that way is used successfully. So the different applications and how they have been used successfully. At this point in the project is still very new. So as far as this specific project, we're unsure. In the previous studies, there have been successful results that have been demonstrated as far as reducing heavy metal uptake in plants and improving plant growth yield in plants such as eggplant, pineapple, and mustard. There have been successful examples previously, yes, in both compost and raw forms. So thank you for your question. I hope that answers it.
Okay, we back again to the chat question. Wenny Beliani.
Yes, Winnie Belliani says, excuse me, sir, let me introduce myself. My name is Winnie Belliani. I am a biology student from Bangka Belitung University. I would like to ask, related to the use of palm oil waste in land reclamation. Considering the potential of palm oil waste in reclaiming former tin mining land, how can we ensure that its application does not introduce new ecological problems such as changes in soil chemistry or heavy metal mobilization? That is a great question. That heavy metal mobilization question especially is interesting. That's something we will see from the essential oil analysis from PT meter IU, whether or not that presents itself, heavy metals present themselves in the essential oils, which will make it difficult to market the product. As far as how can we ensure that its application does not introduce new ecological such as changes in soil chemistry? Well, we are hoping that it does change the soil chemistry because the current soil chemistry conditions on the mine sites are really bad. They're so bad that almost no life can be held in most of the mine sites. So we are trying to change the soil chemistry to improve it. As far as making it worse, one, I don't really know how it could be very much worse than the current like tin mining, other than, but that's one of the reasons why we're doing this study, is doing it on a small scale first and investigating. That's kind of the purpose of this study. And so hopefully the results of this study will heed the results that you're asking about. Again, the study is still new, so we're still working on it, so we don't have all the results yet. But hopefully that's one of the questions that we will have answered later.
Okay, thank you, David.
Yeah.
The next is Anissa Pradina.
Yes. Anissa says, let me introduce myself. I am Anissa Adina, a student from UBB. May I ask a question, Mr. David? Of course, thank you. Considering the potential of palm oil waste in reclaiming former tin mining land. Oh, that's Anissa? Is that?
Oh, sorry. It's, oh, yeah.
That's the
yeah.
same question.
Same. Oh, yeah. Okay. Yeah, this question. I think it's being answered. Agnes.
Yeah, it has been.
Hugo.
Agnes, yeah.
Thank you.
What are the main challenges in restoring soil fertility in post-mining areas in Bangka? I think probably the main challenges lie less in having available materials. It's really about where the money is, I think. And as far as who's paying for restoring soil fertility, because there's the money that's to be had to make money off of restoring mines. It's very far down the road. You have to wait a long time for the soil to be restored until you can plant crops, and then you can plant crops and get money from the crops. But that's kind of a long way down the road, whereas the mining company is usually more interested in just continuing to mine in other places. And I've mentioned it before, but I'll mention it again about where does the money come from, creating economic and political solutions for it. I think that's more of a political and economic problem. I can tell you that in America, we have laws and regulations which say that for every before there is a mining project done, there's a big ecological assessment of the ecosystem of the area. And when there's a law that says once the mining project is finished, you have to restore the ecosystem to resemble the ecosystem that was previously. And that's if that's not done, then the mining company faces huge troubles and they're not able to get permits in the future. Versus here in Indonesia, though the law is certainly not built like that, and it's much more free and open as far as mining companies be able to just go and kind of do whatever they want. And so that is a political thing that certainly is probably the root cause of the issue. Yeah.
Okay, the next one is Muharashia.
Yes.
Yeah,
Okay.
yes.
Excuse me, let me excuse myself. I would like to ask, not far from my house, there is a post-mining area. How can I check whether there is contamination near my house due to the post-mining area, and what is the solution if the area around my house is contaminated? That's a very interesting question. I would say that Well, you're a biology student. You can start with assessing the water and water quality things, such as the pH of the water, and maybe do a heavy metals test on the water. You can buy test strips that you can dip, like pH strips that test for the presence of heavy metals. You could try that and maybe look under a microscope and see if there are microbes or whatnot living in the water. I'm not sure. But the solution, if the area around my house is contaminated, that is tricky. I would bring it up with maybe the local mining company representative for the area. I think that would be your best solution. And if that is the case, which I hope it's not, I wish you the best of luck.
Okay, thank you. The next, Mariani and Shinta.
Yes, okay. Excuse me, sir. My name is Mariani, a biology student from Bangka Belitung University. May I ask a question? Based on the results displayed, it appears that there is a, pH variation between treatments where the Commodore only and the fruit punch compost treatments showed a relatively more alkaline pH compared to the other treatments. May I ask, what are the main factors causing this condition, and what are the implications for soil quality and nutrient availability in plants? So that was just a singular measurement, one measurement in time, and you may be familiar with the saying you need 3 points to make a line. So with it being just one data point, like I'll say it again, this project is still ongoing, so we don't have a lot of data. So you can't really draw implications from one singular data point. We just have to wait to get more data later and then be able to compare it and how the plant citronella grass may respond in the future.
Thank you. Next, Shahwa. Shakira.
Okay.
Yeah.
Xiaohua says, excuse me, sir, I would like to ask if this method proves to be successful, could it serve as a model for reclamation of other mining sites in Indonesia? That is an interesting question. I would say I think so, and I hope so. I think doing in almost any kind of strip mining situation where the totality of the topsoil is removed and it's just left kind of like a barren desert waste, I think the conditions are so bad that doing anything at all, adding any type of organic matter is beneficial than doing nothing. Specifically, like you can read, almost any textbook or on restoration ecology, and it'll usually say the first step is preparing topsoil. That's the first thing that needs to happen in any reclamation process, and certainly adding an organic matter to the existing soil is one of the methods to go about creating topsoil. So I think it is highly adaptable to other mining sites, yes, in Indonesia.
Okay, next, Nira. Nira
Okay.
Erianti. Yes.
Excuse me, sir. My name is Nira. I am a biology student. In hypothesis 1, you stated that organic amendments will significantly improve soil fertility. Statistically, how much improvement is considered significant in this context? Does this statistical significance also mean ecological or agronomic significance for supporting plant growth? That is a very good question, Nira. Thank you very much. And the significance of I can't give you a specific number yet because unlike in like a t-test in a standard a t-test or a p-test, like where the 0.5 is the number that if it's above it, it is significant, or if it's below it, it is not significant. in an analysis of variance test, the significance depends more on the amount of variance that there is. So what is significant and what isn't significant changes depending on the data set and the specific variance within the data set. So, which, because we don't have all the data yet, we don't specifically know. So as far as the first part of the question, can't yet say, but does this significance also mean ecological or agronomic? So as far as the agronomic significance, that will come from mostly how the interactions in the relationship of the soil treatments do or don't affect the quantity and quality of the essential oil. And so there will be a comparison between those two factors, and that will be the agronomic significance.
Okay. The next one is Shalom. You're asking about the water quality. David, Shalom Ayumi.
Yes, thank you, Shalom. I would like to ask, if the water in post-mining land becomes clearer every year, does that indicate that the water condition is getting better in terms of ITS metal content? And is it possible to use it on a daily basis? That's an interesting question. I'm not necessarily sure. I would say that's interesting. I don't necessarily know. I'm not very up to speed on the mining pond the tailing pond reclamation and how the water changes over time. So I can't really give you a good answer on that question, but maybe that would be something to look up. And I'm sure there has been a study done on that question, maybe already published. And if not, then it would be something that maybe you can investigate yourself.
Okay. And then the next is Jenna Veriska.
Okay. Hello, Gina. According to your understanding, given the problem of land use, the availability of equipment and water sources, what strategies are most effective to ensure that post-mining land in Bangka can be rehabilitated ecologically and sustainably? Given the problem, I think as far as strategies go, I think whatever amendment process you use, which we can take the one that I talked about in this presentation, for example, that I think is a very viable option and I think would prove to be an effective option on a large scale. But of course, there are other materials and things that can be used potentially. But I think monitoring is incredibly important as a strategy throughout the reclamation process. Monitoring from start to finish on a routine basis, monitoring before and after, of course, and monitoring a variety of conditions using a scientific basis in order to assess the reclamation process. That monitoring is incredibly important as a
Okay,
strategy.
Yeah, that's from Siti Aziza, not Jenna, but the next is from Kena Veriska.
Okay, Gina, thank you. Facing the challenges of heavy metal contamination and low soil fertility in post-mining areas, how can the use of palm oil waste be optimized to improve soil health while maintaining safe heavy metals levels, while also providing socioeconomic benefits to surrounding communities? How can we use it? That depends on necessarily the goal and the goal of the community, the goal of the reclamation project, the goal and the resources that are available to the surrounding community, and what they can do specifically. How can you, for faster if the community, surrounding community is emphasizing faster, faster reclamation in order to more quickly be able to use the land for different things. Maybe they can invest, and they have the money, they can invest in more processed materials and the time to make those materials, like compost, or even like fly ash material or other chemical fertilizers, as well as the palm oil waste material. But if the area does not have money, and they're okay with waiting longer term, maybe using the raw materials themselves, and waiting while those materials themselves decompose. Yeah.
Okay, thank you. The next one is Shara. Well, time is also limiting now. Is okay. We still have a few minutes. Yeah.
Yeah, maybe two more. Yeah.
Yeah.
Okay. From Ciara, Ciara Permata from Bangka Belitung, I'd like to ask about the case study of orange peels in Costa Rica. They used orange peel waste for tropical forest reforestation and to increase soil macronutrients and micronutrients. Do you think that's good enough for tropical reforestation? And can this method be replicated in other countries experiencing deforestation? And what factors need to be considered? Thank you very much for this question. As far as, do you think that's good enough for tropical forest reforestation? The answer to that is yes, and you can see the evidence of that affirmation in the results of their study. If you go read that study, they used a very simple process. It took a long time, but it yielded very good results in the end. And that's one thing that I think can be replicated here in Indonesia, in Bangka, on tin mines. What factors need to be considered? The most important factor is what materials are there available. So here in Bangka, the most prevalent material is that palm oil waste material. That is the factor that needs to be considered, is what materials are available. Maybe in other countries, they have different agricultural waste materials that are considered. And of course, other factors too, like manpower and how you're going to pay for the process. But really, what kind of most importantly boils down to, what do you have to work with? Yeah.
Okay, the next, Sanjung, probably you can stay on.
Okay. All right. Last question here will be from Sanjung. He says, let me introduce myself. Hypothesis 2 predicts a consistent increase in soil fertility over a 4-month period. However, for organic materials like oil palm and empty fruit punch, which have high lignin content, decomposition can be a very slow process. Isn't a 4-month period potentially too short to truly observe consistent and significant effect? Furthermore, is there no concern that nutrient immobilization, where soil microbes absorb available nutrients to decompose the organic matter, could actually decrease nutrient availability for plants in the short term, potentially counteracting the intended benefits? Sanjung, this is a great question. Thank you very much. And you have very accurately poked holes in some of the flaws in this study. Yeah, absolutely. I mean, the study in Costa Rica, they first measured after 2 years, and then it was final measurements done after 16 years. Unfortunately, I only have 9 months here in Indonesia, so I can't really do a study at that scale. So really just trying to initiate something happening and trying to see if there is a difference that is made over the 4-month period. Potentially there might not be, but I hope that there is. And as far as nutrient immobilization from soil microbes, that's an interesting thing that I haven't necessarily thought of before. It could very well happen. I'm familiar with that concept. And it might be, if that does happen in the test, if the nutrients actually decrease, then it would certainly be true that I've previously mentioned that kind of the next thing that needs to be done is a microbial study. And if that were to be the case, a microbial study certainly would need to be done if those soil nutrients decompose. And I would welcome you, Sanjung, to do that study if that's something you're interested in. So.
Okay, thank you, David. I think we still have another two questions, Fatty and Melda, but I'm afraid that you can answer it online. So maybe the question will be answered in other time and
Okay.
through email. And also you have because time is not permitting. And Ibu Anis also say, thank you for your presentation. So like credit for you. And for the participants, I think we have heard about the project. The project is still ongoing, so some question should be answered later on. And then about the heavy metal, and I think this is maybe related to the purpose of the project is not for consumable. I mean the one we get from when we harvest the citronella, but it's for the oil. But yes, but it's very important. We should take care of it, the heavy metal in. If we use the oil for like as mosquito repellent, and but still have heavy metal in it, so maybe there's a good something to address. And then the benefit of the growing citronella grass is well, carbon sequestration, although it's very, very, very little. But I think there's the beside of the soil amendment, which David focused on. That's also for the economic thing, which will be scaled up if it's feasible. And also there's the projects also leave like the important thing to look at the microbes, as Budiana mentioned, and also the microbes, and also the last thing is about the regulation. I think David mentioned about the regulation in the United States, but we also have also before the project is done, as we should have have a AMDAL, and where there is like a environment assessment, and whereas permitted by the government, then it should be followed. But the thing that is, as you mentioned, David, I think it is relates to the policy and a political thing, and there's also beside the fund. So the willingness of the government, local government and central government doing the reclamation, I think that's very important to us here in Indonesia. I think so. And also about the oil spill, orange spill. I think you mentioned about the availability. What's available in Bangka Belitung or Indonesia and in general. So I think that there's resources that we can use it. I think that's what you mentioned, if I'm not mistaken. Then
Yes. Yeah, that's right.
Do you have a 1 minute for closing statement, David? I will give it to you.
Oh, thank you very much. Yeah, thank you everyone for listening and for your questions. I hope, I'm sorry I couldn't really answer specifics yet. Maybe sometime later down, once the project is complete, I'll maybe give a presentation on UBB campus or something where I can answer those questions better before I head back to America. But this is something that I'm very passionate about, and because I care a lot about nature and ecosystems, and I hope that you all do, and I hope if you didn't really before, I hope you do more now, and I hope that some of the students, there's been a long history of a lot of really good research done on this topic and similar topics to this from UBB, from Professor Nurjaya himself, and of course, some of the other professors mentioned earlier in the studies earlier. So, and I hope that maybe some of the students in this presentation will go on to study similar topics and advance this cause. Yeah.
So again, thank you, David, for your good presentation, and also for the participant. It's a lot of questions, but still you have homework. There are 2 questions it's not answered yet. And I'll pass it to Master of Ceremony. Thank you.
Okay, thank you very much, Mr. David Robert Holdridge, for the presentation, and Dr. Adi Nurcahya, MSc, as a moderator. Before closing today's webinar, let us capture this precious moment with a group photo. We kindly ask everyone to turn on your camera. So everyone, we will take the photo layer by layer. So please get yourself ready. We begin with people on the first screen. Get ready, please. And we will take the photo on 1, 2, 1, 2, 3. Okay, next. The second screen, get ready, please. We will take the photo on 1, 2, 3. Okay. The third screen, get ready, please. We will take the photo on 1, 2, 3. Next. The fourth screen, get ready, please. Okay, we'll take the photo on 1, 2, 3. Next. Fifth screen, get ready, please. We will take the photo on 1, 2, 3. Okay, last screen. Get ready, please. We will take the photo on 1, 2, 3. Okay, next, there will be a symbolic handover of certificate to our moderator, Dr. Adi Nurcahya, MSc. Then there will also be a handover of certificate to our speaker, Mr. David Robert Holdridge. Okay, and these are the names of the most active participants who will receive merchandise from University of Bangka Belitung and AMINEF. Please contact the committee via the contact details listed on the Zoom chat room. So they are Diana Anggraini, Rajita Sahendra, Zamila Nuriza, Siti Nabila, Betty Putri Askia, Selma Gitanusa, Weni Beliani, Anissa Pradina, Agnes Hiko, and Yafik Maharasha. So, okay, everyone, we have now reached the ending of the post-mining land webinar of Biozone 11 2020. Once again, I would like to thank our sponsors today, the University of Bangka Belitung, AMINEF, Mayor of Pangkalpinang, Bangka Belitung Regional Police, PT Asindo Agri, Belitong Resort, BKPRMI, biology lecturers, and biology alumni for the support in this event. We hope Biozone 11 has given us knowledge, inspiration, and unforgettable experiences. See you at the next agenda of Biozone 11. We still have 2 more webinars to come on next Tuesday and 21st of October 2025. Just in case you have registered and if you want to join us, you can access the registration link on the flyer. And for your information, the deadline for international competition of Biozone 11, such as biology quiz, photo competition, poster competition, and environmental documentary video, has been extended to 21st of September 2025. Okay, I think that's all. Let's close our event today by reciting Hamdalah. Wassalamualaikum warahmatullahi wabarakatuh. Thank you and have a nice day. The participants are allowed to leave the Zoom.
At the heart of the Fulbright program, the premier educational exchange program operated in over 150 countries worldwide, are the principles of international partnership and cooperation. For 65 years, the Fulbright program in Indonesia has supported more than 3,000 Indonesians and 1,200 Americans to study, do research, or teach in a variety of disciplines in our two countries. The partnership between Indonesia and the U.S. has been strengthened by AMINEF, the binational Fulbright Commission that has managed the program here for 25 years. This partnership continues to empower talented minds in both countries to experience new environments, contribute to their fields or professions, and inspire those around them.
I think the most memorable experience from studying in the US, the opportunity to meet people from different backgrounds, from different countries, from different cultures. Because when I started to learn about others, at the same time I also learned about myself, about my weaknesses, about my strength, how I learn from others, how I share my experience with others. So we learn from one another. I think that's very important, which I might not ever get in other places. The opportunity to meet people from these, diversities.
Over the last 65 years, Indonesian and American Fulbrighters have made important contributions in many fields: arts, science, economics, English language teaching, and various branches of humanities and social sciences. In a bigger picture, Fulbright has an immense impact on the mutual understanding among Indonesians and Americans. Fulbrighters have gone on to become prominent figures in their respective fields and communities.
Well, what was the important thing is it gave me an opportunity to study. I will never be able to go there to the US on my own. My family cannot support me to go that far. And going to the US was something extraordinarily fantastic at the time.
The Fulbright program continues to inspire the next generation of leaders and the communities which they serve. Through the Fulbright experience, we contribute to the development of both Indonesia and the US and inspire future generations of both nations.